My Faraday Earth Motor demonstration video for the Innovate ECE Ultimate Thread Challenge. I want to start off a little bit with the history on electrical engineering and why I chose this experiment in the first place. On December 25th, 1821, Michael Faraday, the inventor of the first electric motor, recorded a small experiment observing the rotation of a strip of wire caused by Earth's magnetic field. In this experiment, he ran a current through this wire and watched as it rotated upon a pool of mercury. He noted how changing polarity changed the wire's rotation. My purpose upon choosing this project and doing this experiment is when I learned about Michael Faraday's earth motor, I became curious about the physics behind its rotation. And in alignment with the electric energy systems thread, I decided to recreate this and try to implement it in a much safer and more robust method with the purpose of allowing future experimenters to replicate it themselves. Now, the physics behind this motor has widespread application, ranging from power generation to spacecraft maneuverability. An exciting example of this is the ET pack, a device used for deorbiting satellites. The ideation of creating this motor started off with Michael Faraday's original journal, and then online on YouTube I found a video of another professor recreating this motor to not so much as a successful result. His motor didn't rotate very well. So this led me to try to design my own motor by 3D modeling different versions and creating diagrams on how this motor would work. The calculations that I needed to consider to figure out the physics behind this were the torque force generated by the Lorentz force, which is um, uh, the the Earth's magnetic field interacting. In this case, it's the Earth's magnetic field interacting with the current carrying wires of the rotor arms, and the counter torque generated by the surface tension of the conductive liquid, the conductive solution, and the static friction of the surface where the rotor arm is rotating upon. To help with my calculations, I decided to turn this into a computation. I opened up Python and I started coding a script to confirm that the motor would work theoretically, and to find the specifications needed to build the motor. I created this code, accounting for the static friction, the surface tension, and the Lorentz force acting upon the wire arms. In the end, I determined what would be good parameters for this physical motor by finding what worked in comparing the counter torque and the torque generated by different parameters. In experimentation, I separated this into three different steps. The original calculations and computations that we went over, in which I found specifications and parameters physically that would work. And then I continued with designing 3D models to see physically how this motor would look and how I can contain it. And finally, I began testing and observing what this motor did and how it interacted in the real world. My experimentation followed a lot of steps, including mixing the solution, um, sanding down copper to make it smoother, um, assembling the motor container, and of course, watching the motor itself rotate due to Earth's magnetic field. In conclusion, I found that the experiment was a success. Once powered on, the Faraday Earth motor exhibited rotational motion just as I hypothesized. Unexpectedly, though, the motor began rotating with less current than I deemed necessary by my computations. Perhaps an error on my friction side of things, or even in my torque side of things. Moving forward, I saw that hydrolysis proved to be an ongoing issue once the motor was being powered. So adjusting this would be something helpful for future testing, as well as finding a way to better make the rotor arms, because that proved to be a time-consuming task. Diving deeper, I want to answer questions like how do different conductive solutions affect the results, and how much of an impact does the distance between the rotor and the electrodes have? As well, I'd like to explore the electrochemical reactions occurring during the motor's operation inside of the solution. And as a final mathematical test, I'd like to see how I can generate how much energy is generated from rotating the rotor instead of running electricity through it. Some of the resources that I used to make my experiment were Dr. G's Electric Machines Lab, the Invention Studio, and the Hive, as well as these various sources for research and discovery. Thank you.